Hello students, welcome all of you. In this video, I Abhay Kumar going to discuss a very important application of Fourier's theorem in waves and acoustics, which is analysis of a rectangular waveform for B.Sc Part 1 Physics courses. It is lecture number 7 of waves and acoustics. इस वीडियो में हम लोग वेव्स एंड एकॉस्टिक्स में फूरियर थ्योरम पर बेस्ड एक बहुत ही इम्पॉर्टेंट एप्लीकेशन एनालिसिस ऑफ ए रेक्टेंगुलर वेव फॉर्म यूजिंग फूरियर थ्योरम को डिस्कस करेंगे. द गिवन rectangular waveform is shown in figure 1, in which the displacements are given by y is equal to 2a from time interval 0 to t by capital T by 2, and again y is equal to displacement y is equal to 0 from t is equal to t by 2 to capital T. The rectangular waveform is shown in figure 1. The rectangular waveform is represented by the solid curve A, B, C, D, E, F. The time axis is taken through the lowest portion, that is D of the rectangular waveform, while along y-axis displacement of the given rectangular waveform is represented. At time 0 to capital T by 2, displacement of the waveform is 2a. Here y is equal to a0, constant a0 in Fourier series, and it is equal to capital A, which represents the axis of the rectangular waveform, that is OX represents the axis of the given waveform. We know that A0 represents the average displacement of the waveform from the time axis. Time axis is taken along O dash X dash through the lowest part of the rectangular waveform. Lowest part of the rectangular waveform is D. So displacement of this line OX is capital A from the time axis, that is O dash X dash axis. हम जानते हैं कि A0 फूरियर थ्योरम के मैथमेटिकल फॉर्म में फर्स्ट टर्म आता है, फर्स्ट टर्म प्रेजेंट होता है कैपिटल A0, जो कि एवरेज और मीन डिस्प्लेसमेंट वेव फॉर्म का रिप्रेजेंट करता है टाइम एक्सिस से. So during the time interval 0 to t by 2, that is half time period, the displacement of the waveform is y is equal to 2a. That means y is equal to capital A0 will be equal to capital A, that is mean displacement of the waveform from the time axis. So this displacement O dash O is capital A, and again OA, that is the highest position of the rectangular waveform, which is AB. So displacement of AB from this line OX, which is the axis of the waveform, that is x-axis of the waveform, it is also equal to capital A. So total displacement of the of the uppermost part of the rectangular waveform AB from the time axis, that is from O dash x axis, is capital A plus capital A, that is 2A, capital 2A, 2 capital A. And displacement of the waveform y is equal to 0, that is along the time axis O dash x dash. Time axis is taken from the lowest part of the rectangular waveform, which is D. So displacement of this rectangular waveform is 0, that is y is equal to 0 between the time interval capital T by 2 to capital T. This is shown in figure 1. With the help of these two displacements given for a rectangular waveform, we have to obtain the Fourier series of the rectangular waveform. Fourier mathematical form of Fourier's theorem or Fourier series is represented by y equals to function of time t a0 plus sigma r equals to 1 to infinity ar cos r omega t plus br sin r omega t. So Fourier series or mathematical form of Fourier's theorem is given by y equals to function of time t ft equals to a naught. First term is a naught, which is represented by y is equal to a naught is equal to a. Along x axis it is represented by ox, which is represents the mean displacement of the rectangular waveform, the given waveform, which is rectangular waveform form from the time axis. So a0 plus sigma r equals to 1 to infinity ar cos r omega t plus br sin r omega t, and suppose it is equation number 2. And this is Fourier series. This represents Fourier series, that is mathematical form of Fourier's theorem. With the help of this equation 2, that is Fourier series, we have to obtain the Fourier series for the given rectangular waveform whose displacement is given by y equals to 2 capital A from time 0 to time t is equal to 0 to t is equal to t by 2, and displacement y is equal to 0 from t is equal to t by 2 to t is equal to capital T by 2 to time small t is equal to capital T, which is the complete time period. And it is represented by this part of the rectangular, this is the lowest part, which is the lowest part of the given rectangular waveform, which is D, for which displacement y is equal to 0 है इस part के लिए between time interval capital T by 2 to capital T. So we have to evaluate A0, AR and BR, that is amplitude coefficients or Fourier coefficients, and substituting those values in equation 2, we will able to obtain the Fourier series for the given rectangular waveform. Now A0 is given by 1 by capital T integration 0 to capital T y dt. AR is given by 2 upon T integration 0 to capital T y cos r omega t dt, and BR equals to 2 upon T integral 0 to capital T y sin r omega t dt. Now evaluate A0 for the given rectangular waveform, which is shown in figure number 1. So first of all, evaluation of A0, evaluation of A0, and A0 is given by which we have already evaluated in the previous video. So A0 is equals to 1 by capital T integral 0 to T y dt. For this given rectangular waveform, this integration can be divided into two parts, that is from 0 to T by 2 y dt and from T by 2 to capital T y dt. So 1 by T can be taken out, 1 by T can be taken as taken out of the bracket. So we have 1 by T under bracket 0 to T by 2 y dt. For 0 to T by 2, displacement y is 2a. So putting y is equal to 2a for the time interval 0 to T by 2. So it is 1 by T under bracket integral 0 to T by 2 2a y is equal to 2a y dt है. A0 का जो A0 का वैल्यू हमने इवेल्युएट किया था इंटीग्रल फॉर्म में, तो 1 बाई टी 0 टू कैपिटल टी वाई डी टी है. तो 0 टू टी बाई 2 displacement of the rectangular wave form is 2a, so it is 0 to T by 2 2a dt plus integration 0 to integration T by 2 to capital T y dt. Now y is 0 for T by 2, for time interval T by 2 to capital T, displacement of the rectangular wave form is 0. So it is 0 into y. In place of y we have substituted 0 and into dt. So second term is 0, second integral is 0. So it is, we have only 1 by t. First integral survives. So it is 1 by t. 2a is constant taken out of the bracket. So 2a integral of dt is capital T. So upper limit is t by 2 and lower limit is 0. So the value of this integral, that is integral 0 to t by 2 dt is t by 2. So it is 2a multiplied by 1 by t multiplied by 2a multiplied by capital T upon 2. The value of the integral 0 to capital T by 2 dt is t by 2 and 2a is constant. It is taken out of the integration symbol. So we have 1 by t capital T into 2a multiplied by t by 2. 2 and 2 will cancel out, and t and capital T will also cancel out in the numerator and denominator. So we have the value of A0 is capital A, and suppose it is equation number the values of A0, AR and BR. Suppose it is equation number 3 combinedly, all three values combinedly is represented by equation 3, and the evaluated value of A0 का वैल्यू हमने ऑब्टेन किया कैपिटल A. Therefore A0 A naught equals to A, and suppose it is equation number 4. Now we have to evaluate the amplitude coefficients AR of the cosine terms present in the Fourier series. AR is given by AR equals to 2 upon capital T integral 0 to capital T y into cos r omega t dt, which we have evaluated in the previous video. Now for the given rectangular waveform, this integration can be divided into two parts, that is from 0 to t by 2 y is equal to 2a. So 0 to capital T 0 to t by 2 integral 0 to t by 2 2a multiplied by r cos omega t dt, and plus t by 2 to capital T, displacement is 0. So y is replaced by 0 into cos r omega t dt. So write AR equals to 2 upon T is taken out of the bracket as a common. 2 by T को common कर लिया जाए. अब inside the bracket the given integral is divided into two parts. First part is 0 to T by 2 y cos r omega t dt. Y is 2a, that is displacement of the upper part of the rectangular waveform from the time axis is 2a, that is a plus a, 2a. So it is 2a, 0 to T by 2, 2a into cos r omega t dt plus second integral is now, second part of the integral is T by 2 to capital T, time interval T by 2 to capital T, displacement 0. Displacement of the waveform is 0, that is portion D. For D portion, that is the lowest part of the rectangular waveform, displacement is 0 because it is along the time axis. So in place of y, we can write 0 multiplied by cos r omega t dt, bracket closed. Now second integral becomes 0 because displacement y is equal to 0. So we have only the first part, that is first integral inside the bracket, which survives. केवल फर्स्ट इंटीग्रल इसमें सर्वाइव करेगा, सेकेंड इंटीग्रल का वैल्यू 0 हो जाएगा. तो ए आर इक्वल्स टू 2 बाई कैपिटल टी मल्टीप्लाइड बाई 2a is common taken out of the integration, and integral now integration 0 to T by 2 cos r omega t dt. Integration of cos r omega t dt is sin r omega t upon r omega, and limit is 0 to capital T by 2. डिफरेंट इंटीग्रल का फॉर्मूला यूज कर लेने के बाद बिग ब्रैकेट का यूज किया जाता है लोअर लिमिट एंड अपर लिमिट को रिप्रेजेंट करने के लिए. नाउ इट इज 2 into 2a, that is 4a upon capital T. R omega is taken out of the bracket, so it is R omega equals to 2 pi upon T. Omega is angular velocity or angular frequency, which is 2 pi upon T. And now upper limit is T by 2 and lower limit is 0. So we have inside the bracket sin r omega is 2 pi upon capital T, and t is replaced by, a small t is replaced by, time a small t is replaced by the upper limit capital T by 2. So it is capital T by 2 minus sin, lower limit is 0. So sin r omega is 2 pi by t, and t is replaced by now 0. So sin 0. So second term is sin 0. Now t by t in the first term, inside the bracket, t and capital T will cancel out, and 2 and 2 in the numerator and denominator will also cancel out. Therefore we have only sin 0 is equal to 0, second term inside the bracket, and first term is sin r pi, and sin r pi is 0, sin pi is equal to 0, sin 2 pi, sin 3 pi. पाई का इंटीग्रल मल्टीपल में कोई वैल्यू होगा उसका वैल्यू 0 होगा. सो द इंटायर टर्म दैट इज ए आर इज इक्वल टू 0. सो एम्पलीट्यूड कोफिशिएंट्स ऑफ द कोसाइन टर्म्स इज 0 फॉर ए रेक्टेंगुलर वेव फॉर्म. सो ए आर विल एब्सेंट इन द फूरियर सीरीज ऑफ द रेक्टेंगुलर वेव फॉर्म. क्योंकि साइन आर पाई का वैल्यू 0 होगा, तो देयरफॉर ए आर का वैल्यू भी 0 हो जाएगा. और आउटसाइड द ब्रैकेट कैपिटल टी एंड कैपिटल टी विल कैंसिल आउट, एंड 4 will cancel out from 2. So in the numerator, so we have 2a in the numerator, we have 2a upon r pi, and inside the bracket sin r pi, which is equal to 0, and sin 0 is also 0. So 0 minus 0, that is 2a AR is 2a upon r pi multiplied by 0. Therefore AR is 0. So Fourier coefficient or the amplitude coefficients AR of the cosine terms in the Fourier series of rectangular waveform will be equal to 0. So there will be no cosine term in the Fourier series of the rectangular waveform. So the result is AR equals to 0, and suppose it is equation number 5. Hence, the Fourier series, hence in the Fourier series of the rectangular waveform of the given rectangular waveform AR will absent, that is the amplitude coefficients of the cosine terms will absent, that is in the given rectangular waveform cosine terms will absent. Cosine terms will be absent. Therefore, although we have obtained A naught equals to A, but AR is absent, AR is 0. So now we have to evaluate the value of amplitude coefficients BR of the sine terms in the Fourier series. In last, we have to evaluate the amplitude coefficients BR present in the Fourier series given by equation 2 for the given rectangular waveform. We know that BR is given by 2 upon capital T integral 0 to capital T y into sine r omega t into dt. For the given rectangular waveform, which is represented in figure 1, we have displacement of the rectangular waveform is y is equal to 2a, that is displacement of the upper part of the rectangular waveform from the time axis is 2a for the time interval 0 to capital T by 2, and displacement of the rectangular waveform is 0, that is the lowest part of the waveform which is d lies along the time axis. So displacement y is equal to 0 for this part between the time interval t by 2 to t. So we have BR equals to 2 upon t. 2 upon t is taken out of the bracket, 2 by t को कॉमन कर लिया जाए ब्रैकेट के बाहर. So now this integral 0 to t capital T y sin r omega t dt can be written as the sum of two integrals 0 to capital T by 2 y sin r omega t dt for y is equal to 2a, and t by 2 to integral t by 2 to capital T displacement y is equal to 0, so 0 into sin r omega t dt. So we have BR equals to 2 by t. Now 2 by t multiplied by under bracket integral 0 to t by 2 displacement y is equal to 2a, so we can write 2a in place of y, 2a sin r omega t dt plus integral t by 2 to capital T. Now displacement y is equal to 0 for time interval t by 2 to capital T as shown in figure 1. So in place of y we can write 0 into sin r omega t dt. Now second integral, because y displacement y is equal to 0 becomes 0, so we have only the first integral. The first integral inside the bracket is will only survive, केवल फर्स्ट इंटीग्रल ही ब्रैकेट के अंदर सर्वाइव करेगा, प्रेजेंट रहेगा. सेकेंड इंटीग्रल में डिस्प्लेसमेंट, सेकेंड इंटीग्रल के लिए y इक्वल टू 0 होने से t बाई 2 टाइम इंटरवल t बाई 2 टू t के बीच सेकेंड इंटीग्रल का वैल्यू 0 हो जाएगा, क्योंकि डिस्प्लेसमेंट इसमें 0 प्रेजेंट y इक्वल टू 0 सब्स्टिट्यूट किया गया है. सो वी हैव देयरफॉर बी आर equals to 2 upon capital T multiplied by 2a is taken out of the integration. 2a is constant. So 2a, 2 multiplied by T multiplied by 2a into integral, now integral sin r omega t dt, integral over 0 to t by 2 sin r omega t dt sorry, integral sin r omega t dt is minus cos r omega t upon r omega. So integral, now integral 0 to t by 2 sin r omega t dt, it can be written as cos r minus cos, integral of sin r omega t dt is minus cos r omega t dt. So it is minus cos r omega t upon r omega, and limit is, lower limit is 0, t is equal to 0, upper limit is capital T by 2. Now 2 into 2a outside the bracket, it is 4a upon capital T. R omega is taken out of the bracket, minus is also taken out of the bracket, so it is minus 4a upon t multiplied by r omega. Omega can be replaced by 2 pi upon t, 2 pi upon t, angular velocity omega equals to, and inside the bracket now we have minus is taken out of the bracket, so it is minus 4a upon t into r, and omega is replaced by 2 pi by t. r omega को ब्रैकेट्स के बाहर कर लिया गया एंड ओमेगा के जगह 2 पाई बाई टी रिप्लेस कर दिया गया. अब ब्रैकेट के अंदर केवल cos r omega t एंड लिमिट इज लोअर लिमिट, दैट इज टाइम इंटरवल इज t is equal to 0, लोअर लिमिट, अपर लिमिट इज t by 2. So we have cos r omega is 2 pi upon t and a small t is replaced by upper limit capital T by 2. So it is t by 2 minus cos, again cos r omega is equal to 2 pi upon t, and time t, a small t is replaced by the lower limit 0. So it is 0, bracket closed. Now outside the bracket, capital T and capital T will cancel out in the numerator and denominator, and 4 in the numerator will cancel out by 2 present in the denominator. So in the numerator we have minus, it is 2. So term is minus 2a upon r pi under bracket. Inside the bracket, first term t in first term, capital T and capital T in the numerator and denominator will cancel out. 2 and 2 will also cancel out in the numerator and denominator. So first term inside the bracket is cos r pi. ब्रैकेट के अंदर पहला टर्म अब क्या होगा, cos r pi minus second term is cos r into 2 pi by t into 0. So it is cos 0 and cos 0 is equal to 1. So second term inside the bracket is 1, and it is the value of Br which we have obtained for the given rectangular waveform, which is Br equals to minus 2a upon r pi under bracket cos r pi minus 1, and suppose it is equation number 6 from the start. Now if a small r is even, then cos r pi will be 1. That is even means that is r is equal to 2, r is equal to 4, cos 2 pi is equal to 1, cos 4 pi is equal to 1. In that case we have, if r is even, then Br, then cos r pi will equal to 1. Therefore under bracket 1 minus 1 is 0. Therefore Br is equal to 0. Br, the amplitude coefficients of the sine terms present in the Fourier series for the rectangular waveform will 0 for r equals to r is, if r is even. So first situation, if r, small r is even, then cos r pi का वैल्यू +1 होगा, and therefore Br equals to minus 2a upon r pi when r is even. Cos r pi will equal to 1 minus 1, second term is 1 already, 1 minus 1 is equal to 0, so Br equals to 0. Therefore in the Fourier series of the given rectangular waveform, the even term, even sign term will not be present. So now we have to take the value, take r, that is when r is now, when if a small r is odd, then in that case if r is odd, then that is r equals to 1, that is cos pi, cos 3 pi, cos 5 pi, 5 pi, cos 7 pi. तो r का वैल्यू ऑड लेने पर cos r पाई का वैल्यू -1 होगा, और उस सिचुएशन में इक्वेशन 6 बी आर इक्वल्स टू -2a अपॉन आर पाई अंडर ब्रैकेट -1 that is -2 and -2 into -2a, that is 4a upon r pi. In that case br will survive. So now suppose, now let even values of a small r. So if, that is second condition is, in second situation we have if r is odd, then cos r pi, that is cos pi, cos 3 pi, cos 5 pi, all having value is equal to 1. So cos r pi, जब r का वैल्यू ऑड होगा तो cos r pi -1 होगा. जब cos r इवन है, that is cos 2 pi, cos 4 pi, cos 6 pi, cos 8 pi, तो सभी का वैल्यू एक ही वैल्यू होगा, 1 होगा उस सिचुएशन में. देयरफॉर बी आर इक्वल्स टू 0. बट इफ r इज ऑड, देन cos r pi इज इक्वल टू -1. देयरफॉर इक्वेशन 6, that is the expression for Br for the rectangular waveform is given in equation 6. So Br equals to -2a upon r pi under bracket cos r pi is -1, and -1 is present in the second term. Second term is -1. So we have -2a, Br equals to -2a upon r pi multiplied by -1 into -1, that is -2. Therefore Br, that is if r is odd, that is that is amplitude coefficients of the sine terms, that is odd sine terms will survive. So Br equals to -2 into -2a, that is 4a upon r pi, and this is, say it is equation number 7. If r is provided, small r is odd. Therefore the Fourier series, therefore Br, we have obtained the value of Br equals to plus 4a upon r pi. Hence we have only odd sine term, odd sine terms of the amplitude coefficients. 4a upon r pi means 4a upon pi, 4a upon 3 pi. If we take r is equal to 1, which is odd, r is equal to 3, then odd. So if r is equal to 1, amplitude coefficient b1 is equal to 4a upon pi. If r is equal to 3, that is odd, then b3 equals to 4a upon 3 pi. If r is equal to 5, another odd number, then b5 is equal to 4a upon 5 pi. If r is equal to 7, next odd term, then b7 is equal to 4a upon 7 pi. That is only odd sine terms of the amplitude coefficients, that is 4a upon pi, 4a upon 3 pi, 4a upon 5 pi, 4a upon 7 pi, and so on, will present in the Fourier series of the rectangular wave. Hence the complete Fourier series for the rectangular wave is so therefore the complete waveform, complete Fourier series, for the given rectangular waveform is given by y equals to, using equation number 3, Fourier series we have already given. We have represented Fourier series in equation 3 already, which was y is equal to a naught plus sigma r is equal to 1 to infinity ar cos r ar into cos r omega t plus br sin r omega t. तो इस केस में, इस प्रॉब्लम में रेक्टेंगुलर वेव फॉर्म के केस में तो ए आर का वैल्यू, ऑल वैल्यूज ए आर का तो 0 था, तो ए आर टर्म मतलब कोसाइन टर्म्स तो फूरियर सीरीज का रेक्टेंगुलर वेव के लिए कोसाइन टर्म्स तो ऑब्सेंट रहेगा, तो केवल, और साइन टर्म्स में भी केवल ऑड टर्म्स ही प्रेजेंट होगा। इवन वैल्यूज के लिए आर का वैल्यू इवन जब होगा तो उसकी सिचुएशन में बी आर का वैल्यू 0 हो जाएगा, जैसा कि हमने ऑब्टेन किया। सो एम्पलीट्यूड कोफिशिएंट्स ए आर आर एब्सेंट फ्रॉम द Fourier series of the given rectangular waveform. So the entire complete Fourier series for the rectangular waveform is y is equal to a naught. First term is a naught. We have obtained already a naught is equal to a plus ar. Ar is absent, ar is 0. We have already obtained. So only br, and br in vr only odd terms will present. Even values of br, that is even sign terms in the Fourier series is also absent, that is because br is equal to 0 for even value of small r. So we have first term a0 is equal to a plus now odd sign terms, that is first term is 4a upon pi, putting r is equal to 1, sine 1 into omega t, that is sin omega t. Second term is after putting r is equal to 3, sin 3 omega 3 upon, that is 4a upon 3 pi sin 3 omega t. Now putting r is equal to 5, the next sign term or next odd sign term will be 4a upon 5 pi into sin 5 omega t, out of which 4a upon pi is common to all odd terms. So we have a plus 4a upon pi, taking 4a upon pi is common out of the bracket, and now first term is sin, putting r is equal to 1, so it is sin omega t, plus second term is 1 by 4a upon 3 pi sin 3 omega t, and we have taken 4a upon pi common, so it is only inside the bracket we have to write 1 by 3 sin omega t. So 4a upon pi is common, under bracket first sign term is sin omega t plus 1 by 3 sin 3 omega t, plus next term is plus 1 by 5 sin 5 omega t inside the bracket. The third term is if r is equal to 3, we have 4a upon 5 pi into sin 5 omega t, but 4a by pi is common, 4a upon pi common है, इसलिए r का वैल्यू जब 5 सपोज किया जाएगा तो अंदर ब्रैकेट के अंदर 1 by 5 जो थर्ड टर्म होगा 1 by 5 sin 5 omega t and plus so on. That is only odd terms are present in the odd sign terms are present in the Fourier series of the given rectangular waveform, and the first term a0 is present whose value is capital A. So the complete Fourier series for the given rectangular waveform is y is equal to capital A plus 4a upon pi under bracket sin omega t plus 1 by 3 sin 3 omega t plus 1 by 5 sin 5 omega t plus so on. Thus we have analyzed the rectangular waveform using Fourier's theorem. Now this video is completed. Thanks all of you for watching my YouTube channel, Physics Quantum Classes. In the next video of waves and acoustic, we will discuss another very important application of Fourier's theorem.